Hello everyone, welcome to the Chemistry Assistance Club presentation on oxidation numbers and everything related to it. I know this topic is really confusing to some people, so I'm going to do my best way to simplify the topic. This presentation is by me, Christopher Zeuthen. I hope you enjoy. If you have any other questions, feel free to contact me. Alright, so before we get into those really intense problems saying, assign the oxidation numbers to something like KNO3, it's vital that you know the rules to it first. And that's how I kind of learn them, is just, okay, here are the rules, and then let's move on from there. Okay? So let's look at our first rule. First rule, okay. Elements that are in the group 1, so that would be right there, have a +1 charge. Okay, good, kind of self-explanatory. So let's remember when we were doing those balancing equations and all those types of stuff. Next one. If it's a group 2 element, it's going to have +2 charge. So let's remember that these are +2 there. Halogens, which are right there, so all these up and down here, have typically a -1 charge. And then hydrogen, as we all know, is up here, has a +1 charge. The exception of this is if it's with a metal. So a metal is basically all of this area here. So up to about, I don't know, right there-ish. So just know in this kind of general area that's on the left side, those are the metals. You guys kind of remember this stuff. The next one after that is oxygen. So oxygen, which is right there, has a -2 charge. The exception of this is if it's with hydrogen peroxide. So as many remember, hydrogen peroxide is H2O2. So just keep in mind, if you see like that and they say, okay, what is the oxidation number here? So you just keep in mind that oxygen in this case would be a -1, okay? And in any case, and I'm just going to keep H2O2 up here, the oxidation numbers that you assign for each element, the addition of each of those oxidation numbers should add up to 0. That may not make a lot of sense right now, but just keep that in the back of your mind. Okay, the sum of the oxidation numbers, 0. The exception to this is if it's a polyatomic ion. And I'll show you a few examples of that to hopefully make a little bit more sense. Let's get into some of the examples, though, because I feel like that is the best way to understand these rules and make sense of them and actually figure out how to do them. So let's dive right in. Okay, so I'm going to start out with relatively a simpler one, and then we'll dive into some more complex ones. So let's go basically off K2O. So let's see that. Well, let's use our rules first. So let's see if we got anything here. K. Well, let's see. Where is K on the periodic table? It's right here. So it's a group. It's in our group 1. So what does it tell us that it's in group 1? What does that help us with? So it says elements that are in group 1 have a +1 charge. Okay. So one K atom has a +1 charge. But in this case here, we see that we have 2 of them. So one K atom and another one will give us a +2 charge for this. I always like to write what the eventual charge is above it. So we've got a group 1 element, which has typically a +1 charge, but since we have 2 of those atoms, we have a +2 charge. Let's see what's our next one. Oxygen here. Where's oxygen on our periodic table? Okay, oxygen right there. Well, it's not a group 1 element, it's not a group 2 element, it's not a halogen. But we see it's right here. It's one of our special little ones. Okay? So oxygen, it says it's -2, except when it's in hydrogen peroxide. This is not hydrogen peroxide. Remember, hydrogen peroxide is H2O2. So since it's not hydrogen peroxide, it is a -2 charge here. So if they were to ask you, what is the oxidation number of K2 in K2O? You would politely answer, the oxidation number of K2 in K2O is +2. So +2 is your answer. Let's dive right into another one. So now we've got H2SO4. So what is that? Sulfuric acid. Well, let's go by each one individually here, okay? So we've got H2. Okay. Do we know anything about hydrogen? Yes, we do. So hydrogen will be +1 unless it's with a metal, then it's -1. Well, sulfur is not a metal, as it's seen over here, and either is oxygen, which is seen over here. So we know it's going to be +1, but we know since we have 2 atoms of it, we have to add another one. So it's going to be plus 2 overall. That's really bad, plus 2 there. Plus 2 overall. Okay, next we're going to dive into sulfur. Right there. Let's see. Do we know anything about sulfur? Is it a group 1 element? No. Is it a group 2 element? No. Is it a halogen? No. Is it hydrogen or oxygen? No. So we don't know anything about it. So if we don't know anything about one of those elements, because it's not in one of these here, I'm just going to represent it as an X. Okay? Let's move on to our next element, though. Oxygen. Do we know anything about oxygen? Yes, we do. So we know oxygen is a -2 unless it's with hydrogen peroxide. So, and it's not, once again, so it's going to be -2. But since we have 4 elements of it, we can times it by 4. So that'll give us -8. So it has a -8 charge. Well, this is where that last rule that I was telling you about comes into play. So it says the sum of all the oxidation numbers should be equal to 0. Okay? So in this case here, we have plus 2. We don't know what the charge of one of them is, so we say we represent it as X. We know another one's 8, and we know they all have to equal 0. So it's a basic algebra problem. So plus 2 minus 8 is -6. Plus X is equal to 0. And then if we move our 6 over there, X is equal to plus 6. So when they ask, what is the oxidation number of S in sulfuric acid? You will politely respond that it would be plus 6. That is the oxidation number of sulfur and sulfuric acid. Let's go on to another one here. So let's do another, I guess, moderate one, and then we'll do one that's a lot bigger equation, and then we'll start to move on to those other problems that are, the oxidation and blah, 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 the 16 through 36 for the ones that were assigned in Ms. Arthur's class. So let's do if we had CH4. Okay, do we know anything about carbon? No, we do not. It's not up here, so we don't know anything about it. We represent it as an X. Do we know anything about hydrogen? Yes, we do. We know it's a +1 unless it's with a metal. Carbon is not a metal, so thus it would be a +1 charge. And we have 4 of them, so 1 times 4 is +4. And we know that everything has to equal to 0, so what would carbon thus have to be? Have to be a -4. Are you guys starting to get the trend here? If not, I can do some more individualized practice with you or explain it to you in person if that would help anymore. I'm going to do one more basic assigning oxidation numbers, and then I'm going to move into some of those problems that we did more in class of. Okay? So the next example here that we're going to do is, okay, so the next problem I'm going to get into here is definitely the most difficult one that I'm going to do in this video. There's kind of a different procedure. You kind of have to start it out slightly differently. So here's the problem. Find the oxidation number in ammonium nitrite. So finding the oxidation number of the nitrogen in ammonium nitrite. So the first thing that you want to do when you notice that there are 2 different polyatomic ions here, and they're asking you to find the oxidation number, and you're repeated with, you can either look at this 2 ways. If you're repeated with an element, or like in this case you have 2 nitrogens, or if you know you have 2 different if you have 2 different diatomic ions. So in this case, NH4O, NH4, that's not just an element. So if you have 2 elements that make a polyatomic ion if it were by itself. And let me kind of just dive into it here. So the first thing that you're going to want to do here, I'll write this as A here. You're going to want to split them apart like I have here. Split them apart, draw a dotted line, do whatever you got to do. Then you're going to evaluate each one individually. So we're NH4 here and our NO2 here. So we're going to do it like all the other problems we did before now. with one other exception. So since we have broken them apart like this and have to evaluate it in this sense, we have to include what their ion charges would be. So NH4 is a +1 charge. This whole thing has a +1 charge. This goes back to our rule here. +1 charge, and this has a -1 charge. So that's the only difference. So instead of setting this whole thing equal to 0, now we're going to set the whole thing equal to 1 in this case and -1 in this case. But let's kind of go through it in the same procedure last time. Don't get freaked out. Just dive right into it again. So, N here, we don't know what it is. But the hydrogen here, we know what this is. This is common to us. Hydrogen is a +1, but since we have 4, it's got a +4. But now we're going to set it, instead of equaling to 0, it's just going to be equal to 1. And right here too, we have oxygen is typically -2, but since we have 2 of them, it's -4. But we don't know what nitrogen is. So now we're just going to solve for x, just like an algebra problem. Don't get freaked out. So this is going to be x equals 3, and this is going to be x equals +3. And so in this question asks, what is the oxidation number of the N? In this case, the nitrite. So in this case, the oxidation number would be +3. This one is definitely more difficult. I am going to do a second part to this video to kind of go through everything. Go through some more difficult problems, and then also I'm going to be coming out with a third video on redox reactions.